Welcome everyone, and this is our next video, which is provided by the Unix Cloud Fusion. Myself, Ankit. So we are going to go through the Docker Compose, and we are basically going to understand the requirement for the Docker Compose. So we are going to take an example in order to understand the requirement for the Docker Compose. So whenever we are building the applications, you will most probably come across a web application or a mobile application. And let's consider an simple application like this one, in which you visit a browser on the port number 4001. It counts the number of requests that you are number of visits basically for each person which is opening this application. And for this, the backend infrastructure looks like there is a node application which stores, whenever a user visits, it stores that value inside a Redis, and every time a new person visits, it increments the counter by one. Now this is our application which we are actually going to build and run on the Docker container. Now, although we could have built this application entirely inside the Node app without the using the Redis, but the main aim of using the Redis is to show you how if your applications are dependent upon the databases, how we can use the Docker Compose in order to bring the microservices kind of applications up and running. So without further ado, if we take a look at the Docker container, it looks like this. So you might be thinking that okay, so we have to run two applications like Node app and Redis. So we are going to bundle them inside one Docker container and run them. Now, obviously, this can be done, but there is a problem with this architecture, and that problem can be better understood from this diagram. So again, let me just move this a little. All right, now if you have a look at this diagram, what will happen is that your Docker containers, once you scale them out with this architecture, they will have multiple Redis instances running inside the different Docker containers, and whenever page is visited, the node application will be called from a load balancer, and that will make a connection to the Redis. Now your Redis will be having the different values based on the request that has been received by the node application, basically the container. Depending upon it, since the different values will be shown, so you cannot probably judge how many users would have been visited. You would get different values which is not consistent, and obviously this is an issue. So architecturally, you cannot put both the application and the databases inside the same container, otherwise you will face the scaling issues. All right, so going ahead, what could be the possible solution for this? So if we look out for a possible solution, we can use this architecture instead. So again, we are going to create a single Docker container with a node app running on it, and we are going to then we can scale it out and create more containers like that which are running the node application. Now this is a clean architecture for scaling out your application, and always all these applications are going to connect with a single backend, that is your Redis in memory Redis database. Okay, and Redis is going to actually store this number of visits, and because all the containers are now connecting to the same data source, so again, anytime this application gets loaded or whatever scale we think of tomorrow scaling out the Docker container in response to, let's say, the number of requests which has increased on this application, so we can easily count them inside the Redis. So this architecture is going to keep the Redis more consistent. Now, in order to build this up, we are obviously going to start with a single instance first, and we are going to create an architecture where we are going to create one container which is running a node application and which is connecting to the backend Docker container which is running the Redis. So we are basically going to create two containers, Once we have done this, we have the image ready, we can obviously scale as many containers from it as we want. So once we have achieved this architecture practically, then we can move ahead and scale out the node application uh, to as many containers as we want. So again, in our subsequent videos, I'm going to discuss with you how you can build up this architecture for running this application via Docker Compose. And this should give you a pretty good idea as to why we will use the Docker Compose for building such an application. All right, so more will be coming ahead. Let's take a look at uh, how to achieve this in our subsequent videos. Now, normally the problem that you are going to face is over here. Basically, whenever you are going to create the two containers, there is no possible way of actually linking this node container to this Redis container, because the container communication is not supported by default. Uh, Obviously, now in order to support this, you have basically two options. One is using the Docker CLI networking features, in which you manually make the network changes and basically connect these two network containers together. Now, possibly I have never seen anyone using this in the practical environment. So what they do is they simply use the Docker Compose, which brings both the containers up and running together. Now you don't even have to remember the different arguments which you need to pass over the run command in order to make them running. So instead, you just create a Docker Compose file, and when you run them, both of these containers networking is automatically set up so that the one container can talk to the another container. And because Node app is having a dependency on the Redis is also created, and the Node app comes up as well. So both of them are able to communicate with each other, and we get up the application up and running simultaneously. Now just think like this: if you are having the massive number of microservices which are running together and you want to create a local environment on your laptop, Docker Compose can be absolutely beneficial for you, so that it can create all those microservices and you can continue focus on running your own microservice. So again, this is also useful for running the bigger microservices kind of architecture. So if you take a look at Docker Compose is mostly used as a separate CLI, which gets installed when you install the Docker, so it automatically gets installed along with the Docker. Now you are going to use the Docker Compose in order to create the multiple containers together with one command, that is Docker Compose up, and your entire application comes up and running. No more remembering the ports numbers or the different arguments which you have to pass to the Docker run and set up the ports manually. No longer required with the Docker Compose, and it automates the arguments that you have been passing to the Docker run again. So these are all the advantages of Docker Compose. So we have discussed about the Docker Compose till now, and in our subsequent videos we are actually going to do the practical hands-on and see how this can be implemented. I will show you all the code required for implementation of this, and same can be expected when you are working in the production environment. All right, that being said, switch on to our next video, which I will be uploading shortly. Thank you everyone. Do subscribe our channel for getting these videos directly in your inbox.